All right, so let's talk about the heat capacity of water. Heat capacity of water underlines the definition of a calorie. So this is another unit that you may see. I recommend being comfortable seeing calories and kilocalories simply because some of the example problems I might point you to or will have it. On the exam, I probably won't even bother. I don't care to make you switch from calories to joules. So the definition of a calorie, the amount of heat required to raise the temperature of 1 gram of water by 1 degree Kelvin at room temp and at 1 atmosphere. The calorie, although not an SI unit, is often found in biochem, so you may see it more frequently in biochemistry. So like I said, be comfortable seeing it, and occasionally if I just point you to other practice problems that I didn't write, you may have to use this conversion here. 1 calorie is 4.184 joules. So if we want to compare sort of a molar constant pressure heat capacity for ideal gases, we said this is a constant, it's 5/2 NR. So if we're thinking about only 1 mole of an ideal gas, it's 20.78 joules per Kelvin to heat up 1 mole of ideal gas. What do you think the number is for water at room temp, higher or lower? I saw some pens pointing up Yes, absolutely. And again, this is because it has potential energy. It has bonds. It has molecules actually bumping into each other, and we're not imagining that that's not really happening. So water at room temp requires 75.33 joules, or what is that, 3-ish, 3.5-ish times as much, 3.25. Yep. And again, this is because when we think about where does the heat go, in an ideal gas, it all goes exclusively to increasing kinetic energy. It all goes exclusively to raising temp. Whereas as soon as we have a more complicated system, which is all of our biological systems, they're all in water, and then there's stuff in the water too. So some of it will go to raising or increasing kinetic energy and raising temp, and that's sort of indicated by maybe these faster, longer arrows they're moving. But some of those things are going to go, like I said, into actually rotating bonds, stretching and vibration of the bonds, flipping from from cis to trans to cis. Trans conformation is better and lower energy. Cis will be a higher energy state, so it'll be maybe excited into some higher potential energy mode.